Hello aspirants, welcome to e-Vivekaam. Today's theme is nuclear energy. First, we'll see why do we need nuclear energy. For many years, we have used fossil fuels like coal, petrol, diesel and other gases to produce electricity, to run vehicles and for other industries. But now we are trying to use cleaner and better energy sources because fossil fuels take millions of years to form and we are using them too fast. One day they will be gone. And also, by burning these fossil fuels, it creates smoke and also releases carbon dioxide and also other pollutants which make earth heats up, and too much carbon dioxide traps heat in the atmosphere make the earth hotter. This causes more heat waves, floods and storms, which means they cause climate change. So that's why we are moving towards the cleaner energy, that is renewable energy. We know renewable energies like solar, wind, hydropower and also nuclear energy is a renewable energy. Unlike these three, they depend on whether nuclear energy is always flow of energy. Now let's see the definition. By breaking down the term itself, we'll get the definition. The energy which is released from the nucleus of an atom when it undergoes fission or fusion reaction. Here fission is splitting the atom, fusion is combining the atom. The energy which released is converted into heat, which is then used to produce electricity. For now, we are using fission reaction to produce the nuclear energy because fusion requires greater temperature to produce energy. Here in fission reaction, a small amount of fuel can produce a lot of energy. Now, we'll see how nuclear energy is produced. Generally, coal, oil and gas is used to produce electricity, but here we use uranium, plutonium and thorium to produce electricity. Plutonium-239 and thorium. Now you may have question like, why only these three used to produce nuclear energy? If you remember, in the definition itself it said that we break the atom to produce the energy. Here, uranium, plutonium and thorium can be easily breakable compared to others like lead, iron and other elements. So, we use these three to produce the nuclear energy. Here, if we see, we have two types of uranium. They differ based on the protons and neutrons that we don't require for the exam. This uranium-235 can be easily breakable, but its availability is only 0.7%. This uranium-238 present 99%, but it is not easily breakable. So, when uranium is placed in the nuclear reactor, it absorbs some neutrons and becomes plutonium-239. This is also used as fuel to produce nuclear energy. Here, plutonium does not available naturally. You should remember this. Uranium and thorium available naturally, but plutonium doesn't available naturally. They absorb neutrons in the nuclear plant and becomes plutonium-239. Here thorium is also placed in nuclear reactor and becomes uranium-233 to produce nuclear energy. Here these two are not easily breakable, so we are converting them such that they can be easily breakable and produces. We have three different stages to produce them. Let's discuss that later. Now let's see how nuclear energy is produced. The uranium placed in a nuclear reactor hit by a neutron so that the atom splits and produces heat and also more neutrons. The extra neutrons hit more uranium atoms and it creates a chain reaction, and this reaction continues. This heat from fission boils the water which produces the steam. This steam produced is used to spin the turbine which produces the electricity. Here the uranium hit by neutron, then the atom splits here and produces heat, nothing but energy and also some neutrons. These neutrons again used to split the atoms of uranium, and this continues. It becomes a chain reaction here, and this heat is used to boil the water which produces the steam. This steam is used to spin the turbine which produces the electricity. This is how nuclear energy is used to produce the electricity. This also has some challenges like the disposal of nuclear waste is a major environmental and safety concern. It releases some radioactive waste which needed to be disposed safe. It releases some radioactive waste which needed to be disposed safely. and also it requires high initial costs, and this waste also can be used for making weapons. They may be misused, and there are also risks for nuclear accidents. These are the challenges for producing the nuclear energy. If we see the deposits of uranium and thorium, thorium is more abundant than uranium and produces less nuclear waste also, and we have only modest uranium reserves here. And we have one of the world's largest uranium reserves in Andhra Pradesh. Other uranium reserves we have in Jharkhand, Karnataka, Meghalaya, and also in Rajasthan. But here thorium, we have 25% of world's thorium reserves in India. Major thorium deposits we have in Kerala, Tamil Nadu, Andhra Pradesh, Odisha, and West Bengal. If we see the world, Australia has the largest uranium reserves, next Kazakhstan, these may ask in prelims, and next Canada. But largest producer of uranium is Kazakhstan. Here Australia exports more uranium. It is the largest producer. Coming to thorium, first India, it has largest reserves of thorium, next Brazil, then Australia, then US, etc. As India has vast thorium reserves, Dr. Homi Bhabha designed a program called Nuclear Power Program, which aims to gradually transition from uranium-based to thorium-based reactors, which was divided into 3 stages. Now let's see that. In stage 1, we use pressurized heavy water reactors to produce the nuclear energy. In this stage, we use uranium as a fuel to undergo the fission reaction and to generate heat. In this process, plutonium-239 is created as a byproduct which is used in the second stage. These nuclear plants are present in Kakrapur, which is in Gujarat, and Tarapur, which is in Maharashtra, and Narora nuclear plant in Uttar Pradesh. Remember these places also they may ask in prelims examination. Next, stage 2. Here we use fast breeder reactors, FBRs, to produce more fuel. Here we use the plutonium which is produced from the stage 1 to create more fuel than it is consumed. FBRs are also use thorium. In the process, thorium is converted into uranium-233, which is a new nuclear fuel which will be used in the next stage, means in stage 3. These reactors are present at Kalpavruksham in Tamil Nadu. Now in stage 3, we use advanced heavy water reactors, which uses this uranium-233 as a fuel to produce the energy. And these reactors produce lesser nuclear waste and also safer. The Bhabha Atomic Research Center is working on this advanced heavy water reactors. That's why we say that uranium is the present, plutonium is the bridge, and thorium is the future of the nuclear energy in India. Here in stage 1 we use uranium as a fuel, but we get a byproduct plutonium-239 which is used in stage 2 as a fuel, and in this stage 2 thorium is converted into uranium-233 which is used as a fuel for stage 3. Here in stage 1 it leaves radioactive waste that needs to be disposed safely, or else they may use it for making nuclear weapons. But in stage 3, it leaves very less waste and also considered safer. Now let's see some key organizations which may ask in the prelims examination. First one is Department of Atomic Energy. It was established in 1954 to oversees India's nuclear power. Next, Bhabha Atomic Research Center. It is India's primary nuclear research center in developing reactors, fuel, and also technology. It also researching on this third stage, advanced heavy water reactor. Next, Nuclear Power Corporation of India Limited, NPCIL. It is responsible for building and operating nuclear power plants. Just remember this much, it is sufficient for the exam. Don't go into details of these organizations. Next, Atomic Energy Regulatory Board, which regulates the nuclear safety and radiation protection and also waste management like radioactive metals. Next is Uranium Corporation of India Limited. It manages the uranium mining and the processing in India. Uranium mining and processing. Next is Indira Gandhi Center for Atomic Research. This organization develops the fast breeder reactors technology. This was asked in previous exam of UPSC Prelims. Next one is Board of Radiation and Isotope Technology. It focuses on the radioisotope applications in medicine, agriculture and also in other industries. Coming to international organizations, International Atomic Energy Agencies, which oversees the global nuclear safety and India's civilian nuclear program. Next, NSG, which is Nuclear Suppliers Group, which aims to prevent the nuclear proliferation by controlling the nuclear material trade. It controls the nuclear material trade. And the next, Test Ban Treaty Organization, which monitors nuclear test bans. India has not signed this. If we come to the acts, we have Atomic Energy Act 1962, which regulates the nuclear energy development, safety and also the usage of nuclear energy. That's it for basics.